This is 1.3 composition of pure substances. So our outcome is I can explain the quantitative relationship between the elemental composition by mass and the empirical formula of a pure substance. So this picture here is showing a common method for determining the formula of a hydrocarbon. So a hydrocarbon involves burning the hydrocarbon in the presence of oxygen. So all of the carbon is converted to CO2 and all of the hydrogen is converted into H2O. So in this diagram, if we measure the mass of these absorbing chambers before and after, we can calculate how much water was produced and how much carbon dioxide was produced, work backwards to get moles of carbon, hydrogen, and oxygen, and find the empirical formula. So using the method that was just described in that diagram above, we're going to combust a sample that's made from hydrogen and nitrogen and carbon. At the end, we produce this mass of carbon dioxide and this mass of water. So our first step here is just to convert grams of carbon dioxide into grams of just carbon, because we want to get the percent by mass of each of these things. So this is in grams, which means that I need to get the mass of carbon in grams and hydrogen and nitrogen in order to solve. So first I'm going to change carbon dioxide from grams to moles using molar mass. Then I know that in every 1 mole of carbon dioxide, there's 1 mole of carbon. Then I'm going to use the molar mass of carbon, and that gives me my answer here. So I'm going to do the same thing with hydrogen, except this time I'm using H2O in order to get to hydrogen. Then, if I want to find the percent by mass of carbon, I just have to take that mass of carbon that we found and divide it by the total mass of the sample. So that's how we got this percentage here. I did the same thing to get hydrogen. And here I just subtracted the percentage of carbon and hydrogen from 100 because we know that the rest of it then has to be nitrogen. So in this next question, it says, what if during the experiment the flow of oxygen is interrupted? So we get an incomplete combustion and we form carbon monoxide instead of carbon dioxide. So how would this impact the percents? So in the diagram, there's nothing to absorb carbon monoxide. I can only absorb water and carbon dioxide. So what that means is that if I form some CO, some of that carbon is going to escape and go unaccounted for. And this is going to give us a lower percent composition for carbon than what we got. So this would make our empirical formula carbon light. So here are the correct percentages that you should have gotten from the last problem. We want to use this to determine the empirical formula, and there's a quick video that you can watch if you need a tutorial. So I'm going to assume that I have 100 grams of this substance, so then that means that I have 38.67 grams of carbon. So I'm going to convert that into moles, and I'm going to do that for carbon, hydrogen, and nitrogen. And I get my answers here. Then I'm going to divide them all by the smallest number of moles so I get a ratio. And I end up with 1 to pretty much 5 to 1. Now, if you had used your masses that we had found in this first problem, you would have ended up calculating the same ratio whenever you do this problem. So the empirical formula is the simplest whole number ratio of atoms in a molecule. The molecular formula is some multiple of the empirical formula. So for example, glucose is 6 times the empirical formula of CH2O. So if we want to know the exact formula of a molecule, we're going to need to see how many times the empirical molar mass goes into the molar mass of the compound. So the molar mass of this compound is 30.06. And experimentally, we found the molar mass to be 62.1. So what that means is that there's about a 2 times ratio here. So the empirical formula is going to be double, or I'm sorry, not the empirical formula, the molecular formula is going to be double the empirical formula. So in our reflection questions here, talking about the law of definite proportions, water is always going to be a certain percent hydrogen and a certain percent oxygen, because the formula for water is H2O. So there's always a relative mass of those two elements in the compound. And if it doesn't have the correct percent composition, it's not H2O. Without doing any calculations, which has the greater percent by mass of hydrogen? So we know that hydrogen is about 2. So that makes water about 18, and that makes hydrogen peroxide about 20. So what's bigger, 2 out of 18 or 2 out of 20? So 2 out of 18 is going to be a little bit larger. So we know that H2O will have a greater percent by mass of hydrogen.